Welcome to Get Your FRQ On. This question is from 2006. It's question 4, and it is not calculator active. In the question stem, we have a rocket A. Rocket B will show up at a later point in the question. And we have a table of values for the velocity of rocket A for various times from t equals 0 to t equals 80 seconds. We are also told that the initial height of the rocket at t equals 0 is 0 feet, and the initial velocity from the table of the rocket A at t equals 0 is 5 feet per second. In part A of the question, we are asked to find the average acceleration of rocket A from t equals 0 to t equals 80 seconds and to give the correct units. Well, since acceleration is the derivative of velocity, and we have a table for the velocity, we can find the average acceleration by finding the average rate of change of the velocity on the interval from 0 to 80. All right, well, we can use a formula for that. The formula for average rate of change over an interval is just v of x2 minus v of x1 all over x2 minus x1. Great. So we plug our information from the table into the correct formula. We need v of 80 and v of 0. v of 80 is 49. v of 0 is 5. 49 minus 5 is 44. 44 over 80 reduces to 11/20. And since our velocity is feet per second, our acceleration will be feet per second. So the average acceleration of rocket A over the interval from 0 to 80 seconds is 0.55 feet per second. In part B of the question, we are asked for the meaning of the definite integral from 10 to 70 of v of t dt, and then asked to find that using a midpoint sum and 3 equal intervals. Because v of t is a velocity function, the integral from 10 to 70 of v of t dt would just be the net change in the position of rocket A over that interval from 10 to 70. Using the midpoint formula and 3 equal intervals, the value of this integral from 10 to 70 of v of t dt is 20 times v of 20 plus v of 40 plus v of 60, which would be 20 times 22 plus 20 times 35 plus 20 times 44, which turns out to be 2,020 feet. In part C of the question, we are introduced to rocket B. Rocket B has an acceleration function of 3 over the square root of t plus 1. We are given that this is equal to 0 at t equals 0, that the velocity of rocket B at t equals 0 is 2 feet per second, and then we are asked to determine which of the two rockets, rocket A or rocket B, is moving faster at t equals 80 seconds. All right, so really what we need to do here is we just need to find the velocity of each rocket at t equals 80 seconds. So based on the data in the table, rocket A is moving at 49 feet per second at t equals 80. Okay, that's just straight from the table. Getting the velocity of rocket B at time t equals 80 requires us to find an antiderivative for A of t, since we don't want the acceleration here really, we want the velocity, so we're going to have to find a velocity function ourselves. So if the acceleration of rocket B at time t is given by 3 over the square root of t plus 1, and v sub b of 0 is equal to 2, then we can find a function for vb of t. All right, so that would be the antiderivative of 3 over the square root of t plus 1, which is 3 times the integral of 1 over the square root of t plus 1 dt. Use the power rule for this, I think, would be okay. We have 3 times 2 times the square root of t plus 1 plus a constant. So we get 6 times the square root of t plus 1 plus c. We do need to take into account the initial condition, since at t equals 0, we know this is supposed to equal 2. vb of 0 equals 2, which is 6 times the square root of 0 plus 1 plus c. And we get c equals -4, so our velocity function for rocket B would be 6 times the square root of t plus 1 minus 4. Well, if I need to know the velocity of rocket B at t equals 80, I can just plug in 80 for t. 80 plus 1 is 81. Square root of 81 is 9. 6 times 9 is 54. 54 minus 4 is 50. So the velocity of rocket B at t equals 80 is 50 feet per second, compared to the 49 feet per second for rocket A. Rocket B is traveling faster at t equals 80 seconds.